Hello guys, my name is Reza and this is our first tutorial of the course Python Tutorials. In this course we are going to learn Python fundamentals. We'll write code together, learn the basics and get prepared to find a job as a Python developer. But first of all, let's see why should we learn Python. There are a lot of reasons why Python is getting popular these days. There are a lot of job opportunities for Python and we are going to discuss the reasons. The first reason is that it is easy to learn. The purpose behind designing Python as a programming language was to make it easier for people to write codes. There is less amount of code to write and it is designed in a way to be closer to human language. And of course it is platform independent. You can write your code on your Mac system, on your Windows application, on Linux, and independently from the structure of the system you're writing, you can run the code on all other systems. You just need the interpreter to interpret your program. There is a massive community support for Python. There are a lot of people who are working to write pre-built libraries for you to answer your questions and support you throughout writing codes in Python. And these were only some of the reasons why Python is getting so popular these days. And now that we have learned why Python is attracting a lot of attentions these days, we have to download and install Python 3 interpreter. But what is an interpreter? We know that Python is a high-level programming language, which is not exactly what the computer, what your machine can understand. You need an interpreter to translate your code into machine code in order to make your computer understand what you mean. And then we have to install Python interpreter in order to translate our code into machine code. Then we need a text editor. What is a text editor? You can write your code in Notepad or Notepad++ or whatever. But the problem is that when you write codes in simple text editors, the keywords are not highlighted. You cannot debug your code, solve the problems, and there are no suggestions in that. So we need an IDE, integrated development environment. PyCharm is one of the best for Python programming. It highlights the keywords, eases your programming, and of course makes you able to debug your code. And then finally, after installing the interpreter and the text editor, we will write our first program in Python and then we will run it to see how Python applications work. Alright, the first step is to download Python interpreter. In order to do that, I will type Python download. And then here the first choice is from the python.org website. It will give you the most recent version of Python interpreter available. Now at the time of recording this video it is Python 3.8.2. I will download it and when the download finished I will open it. There are two choices, install now or customize installation. I will choose install now, but the most important thing is to add Python 3.8 in path. It is very important to remember. If you don't check it up, and when you write the program cannot find this interpreter. So we will check it here and install now. It will take a bit to be installed. Now that everything is done, we will close this one. And now we need to test whether it is installed successfully. On Windows systems, you just need to click on the Windows button and write CMD in order to open command prompt for you. After command prompt gets open, we have to write Python -- version to see the current version of Python. We can see that okay, it is 3.8.2, and then we will run Python in order to write a small code. We'll write Python and press enter. Python interpreter gets open. We'll write a very simple program now, just adding 2 and 3 together just to test if our code is working. And then we are expecting 5 to be printed. Okay, so the program is working and Python is installed successfully. We'll close this one And the next step is to download PyCharm. We'll write PyCharm, download, and then using jetbrains.com, we will download the PyCharm application, which is a text editor. There are two versions available, professional and community version. Professional is of course the complete one, which have the SQL support and so on, but we will need the community one, which is the free one. We will press download and then we'll wait until download finishes. Okay, the installation starts. We'll just click on next and keep the path as it is. You can of course change it if you like. The capacity needed is written here. We'll click next. We can set the system. I will choose 64 bits, which is my machine. And of course the other important thing is to choose the associators to py, which is the extension for Python files. I will press next and then install. It will take a bit to be installed. We will wait. I'm not going to pause the video because it is not going to take a long time. Alright, I would like to launch it, so I will check this one here and then finish. The first time that PyCharm gets run on my system, it will ask me for some configurations. First of all, it asks for privacy policy. I will check it here and accept it. Data sharing, I'm not interested in data sharing, so I will decline it. And then here it asks me for a theme, the Darkula or the dark one or the light one. I prefer the dark one, that is up to you. I will choose Darkula as my favorite one. And then here if it asks me if I like IDEA, Vim, R language support, Amazon Web Service tools, and so on. I will skip this for now because for this course we don't need any of these. So I will just skip it. And then the first time PyCharm opens, it asks me whether to create a new project, open a previously existing project, or get from a version control like Git or something else. I would just like to create a new project. We will call it Hello World as our first project. And we have to keep in mind to have the interpreter that we just installed, which is 3.8. There are other options, but we will keep this one. And then we press create. And we'll wait a bit for PyCharm to create our project and build the dependencies. I don't need the tips and tricks, so I will ask not to show it again. It takes a bit to provide the project for us and build all the dependencies, and of course load Python libraries inside the project. When it is done, you can see that my project is ready. You can see Hello World here, which is my project, the one I built. And of course, the libraries are added here. The libraries from the Python are added. I can use them in the course further. I will tell you what these Python 3.8 libraries are. For now, we'll just right click here and create a new Python file where we need to write our program in. So I will say it again, right click, new, and then Python file. And then write our name, our desired name. I will write first here because it is our first program. And then you can see that this first appears here, first.py. And then I will just write a very simple code. I will just want to print on the screen Hello World to the user. So it is a very simple program. I will write print, and then in the parentheses and in the double quotations I will write Hello World. If we run this program, only this line would be shown to the user. I will run it. It will ask me which file you want to run. I will choose first, and then you can see hello world is printed on the screen. In this tutorial, we are going to talk about variables and data types in Python. In order to understand the variables, we have to know that variables are containers in which we can put different data types. Different data types are like numbers, are like strings, names, and so on. In this tutorial, we'll go in details talking about these data types and how we create the variables. The first important thing about creating a variable is to giving a name to it. We call it the identifier. Imagine that we want to store information about a person. The first important information is a first name. So we'll write first name, and then in this first name we will put his first name, but of course we have to remember that all the strings and characters must be put in double quotations. Imagine that his first name is John, so we'll put it inside double quotations. Python understands that this variable is containing a string because it is inside double quotations. You could write, for example, Alex, or you could write even the last name, for example, Alex Brown. So you can put whatever you like inside a string. You can put even multiple lines. Python understands that this is a string type. The other data type in Python is the numbers. For example, we want to store the age of this person. So we say age equals to, for example, 34. So Python understands that this variable contains numbers from now on. You can have whole numbers like this one, or you can have integer numbers. As you can see here, it is recognized as an integer number. If we called it like this, it would understand as a float number. So in Python, we have got different types of numbers, but Python understands that this is a number. And the last data type in Python is the Boolean data type. For example, we want to know if this person is male or female. Of course, we know that Alex is a guy, so we'll call it true. So this guy is a male, and here we will see that the data type is understood by Python. It is called Boolean, and it is set to true or false. These are the only two values that we can give to booleans. So we'll reset this to true, and then, as you remember from last session, we can print the information for the user by using the keyword print, as you see. And then imagine that we want to print the first name. From now on, if you write the first characters, Python understands that you mean first name, or even if you had other variables with the FIR startings, Python would list them for you, and then you can choose among them. You want to maybe write the age of the person, and finally you want to print if he is male or not. Before running this project, I want to just mention some information. First of all, if you see, I have used underline here. There are some naming conventions for the variables in different programming languages. Some of them prefer camel case. Camel case is like this. You start the first part with the small letter, and then the other nouns that come afterward will start with a capital letter. So first name is like this. There is another convention called Pascal. You write all the nouns with capital letter. And of course there are other types like Hungarian notation that we use the types at first and so on. But in Python we write everything as lowercase, and we divide different nouns with underline. This is very important to notice that if it is a class name, in the future we will learn that class names start with capital letters. But for now, remember that the variables are all written in small letters, and if they are compound nouns, we have to divide them using the underline. Now, if we run this program, you can see that all these values are written together for you in separate lines. First name, age is male, Alex Brown, 34, true. The last important thing about variables is that if you write another value on a variable, like for example if you want to change our first name to John again, here John is overwritten, so first name is not Alex Brown anymore and John is written in first name. Programs in Python are read sequentially starting from the first line. It reads the first line and assigns Alex Brown to first name, then it reads age and assigns 34, is male, assigns true. If you write again first name, it will give the new value to first name and it will forget about the one you gave it before. If we run this application again, you can see that John is now written instead of Alex Brown. So in this tutorial we talked about variables and data types. We understood that variables are the containers and we have got 3 different data types in Python that the variables can contain. These different data types are strings, which are a set of characters. It can be even a full sentence or a full book. The other type is numbers. You can put all types of numbers, whole numbers, integers, float numbers, and the last data type is the Boolean data type, which can have only true or false. Remember that these data types are the primitive data types that Python supports. You can have data types with different structures in which there are more than one primitive data type. In the future, we will talk about them in details. In this tutorial, we're going to talk about strings. But what are the strings? The strings are a set of characters. They can be a word, a sentence, or even a whole book. Let's talk about strings in details using some examples. Imagine that you've got a phrase, and a phrase contains a string. For example, Vision Academy. You can see that in this string we have got capital characters and small characters. And this string is made up of 2 different words with a space in the middle. If we print this word, as you know, you will see this like here, Vision Academy. You could even use this string directly here and you would have the same results, as you can see, but we will prefer to put everything inside a variable, and this variable contains this string from now on. But we can do a lot of other things on the strings. There are a lot of pre-built libraries to work on the strings which are available in Python 3. Imagine that on this string you wanted to write Vision on one line and Academy on another line. You could use \n, which is used for going to another line. So in this way you will have Vision on one line and Academy on the next line. Let's run this code. As you can see, we have them on 2 different lines and there is one small space here, and that space is the one we have got after \n. You could also have \t. \t means to go a tab forward. You can see the results here. We are going 4 spaces forward. Imagine that you wanted to put Academy inside double quotations. You cannot put Academy like this inside double quotations. The reason is that double quotation is a character which is reserved by Python in order to show starting and ending the strings. So if Python sees this double quote here, it considers that the string is finished here. So your string was Vision. In order to make Python understand that this double quote is the real double quote that I want to use inside my string, again you use a \. So \/ is used for special characters, something like double quote, \t, \n for special characters. If we run this code, you can see that Academy is put inside double quotes. Let's get rid of these extra parts and talk about some other capabilities that we have on the strings. Imagine that we will have another phrase called phrase 2, and then we want to have phrase 1, and we want to add another string to phrase 1. We can do that by simply putting a plus and then adding another string. For example, is nice. If we print this second word, which is phrase 2, you can see that is nice with a space at first is concatenated to Vision Academy, and then phrase 2 contains all the sentence. If we run it, you can see that first we printed phrase, which is Vision Academy, and then secondly we printed phrase 2, which is Vision Academy together with is nice. There are also some functions that you can implement on your strings. What is function? We will talk about that in our tutorial related to function. Just for now, you have to keep in mind that function is a machine that takes something as an input, does some action on it, and then gives you back some values. So consider a function as a machine. And now we want to see which functions are available and pre-built in Python for the strings. One of them is len. You can print the number of characters that exist in phrase with the keyword len, which is a function, by passing a string as an input argument, which is inside the parentheses. You can ask the length of this string. What is the length of a string? The number of characters inside a string. As you can see here in Vision Academy, we have 1, 2, 3, 4, 5, 6 for Vision, and 2, 4, 6, 7 for Academy, 13, and one space, 14 characters are here. So len phrase should print 14 for us. As you can see, 14 is printed here. But there are also other pre-built libraries. For example, we can transform a string to lowercase. It is just enough to write lower, and then it will change all the characters into lowercase. Here we have got V and A as uppercases, but if we run this program, you can see that here V and A are also changed into lowercases. We could do the same by writing upper. In this way, everything will be changed to uppercase letters. As you can see here, Vision Academy is printed totally in uppercase. But what if you didn't want to just print this string in uppercases? You wanted to store it somewhere. So you could create another variable, for example, phrase upper, we will call it, and then we will put phrase dot upper. Then we have everything in uppercase inside another variable. So as I told you, a function will return you something, and the return value can be assigned into a variable. We can print this one now, and you will see that we will have the same results here. Another thing that you need to know about strings is that in a string, all the characters can be accessed one by one by their indices. Index starts from 0. So V here in the Vision Academy has index 0. I has index 1. S index 2. I index 3, and so on. So you can access each of them by their index. But how can we use these? If we print phrase 0 like this in the brackets, you can write the index and then you can access index 0. If we run this program, you should see only a capital V. As you can see here, capital V is printed for you. So if we wanted to see phrase 3, it is 0, 1, 2, and 3. This I is going to be printed on the screen. Let's check. I is printed. You can access index of a character or a substring inside a string. But how can you do that? by writing the name of string dot index. And then inside the index you can write whatever. For example, I want to see where capital A is. It returns 7, which means 0, 1, 2, 3, 4, 5, space is 6, and 7. This is the index of capital A. If we wrote I here, it will return 1 for us because this I is 1. So the other I is not considered. It is very important to notice that if you write index, it searches inside your string and finds the first occurrence of this substring and returns the index of that. Imagine that we wanted to check, for example, academy. What do you think it will return? Let's see. 7 again. Why? Because it starts from here. It doesn't care where it goes. It tries to find exactly this substring inside this string, and as soon as it finds it, it returns you the index of the first part or the first character of your substring, which is 7 here. If you misspelled something and then you wanted to search for A, C, D, E, and Y inside it, because this substring doesn't exist here, it will give you back an error. As you can see, it says substring not found. So you have to be careful to search correctly in your string. This is the way to find a substring inside a string. Another useful thing that you can do is that you can replace some parts of your string with other strings or substrings. How can we do that? Imagine that in phrase 2, we want to replace nice with, for example, not bad, like this. This function takes 2 input arguments. The first one is the substring that it is going to search for in your string, and the second one is the one which is going to be replaced. So it searches in phrase 2, which is Vision Academy is nice, finds nice, and replaces it with not bad. Let's run it to see. Vision Academy is not bad. You could change only one character. For example, we want to change all I's to capital G. Let's run the program. You can see that VGSGON Academy GSNGC. So it has replaced all I's with capital G. There are also other methods available on the strings that you can use them. For example, if you write phrase or every string and you put a dot after that, you can see the available methods that you can implement on this string. As you can see here, the list goes on. In order to get the complete list, you can go to python.org and see the complete list and their functionalities. That was it about strings, guys. I think we know now enough about strings. If you've got any questions about strings, please ask me in the comments. I will answer as soon as I can. And if you like this video, please subscribe to our channel and encourage us to create more videos. In this tutorial, we're going to talk about numbers. But in order to talk about them, we need to go through some examples. As you know, numbers are one of the primitive types in Python. Primitive types are numbers, strings, and Boolean values. Today we're going to talk about numbers. Imagine that we have got a variable called num1, and we will give the value of 10, for example, to it. Then we have another variable called num2, and we will give value 5 to it. For example, imagine that we have got a variable called result, and we are going to do some operations on num1 and num2. We can add num1 to num2, and then imagine that we want to print their results. So if we run this program, As you can see, we have 15. Number 1 is added to number 2. We could even add something else to it, for example 25, so the results would be 40 if we run the program. As you can see, we can also have other mathematical operators like minus. As you can see, we can multiply two numbers, or we can divide two numbers. As you know, the division result of num1 and num2 is 2, and the division result is a float number, is a whole number. So if it was 3, as you can see, this is the result, 3.3. But what if we wanted the remaining? We could have that by using the percent sign. So in this way we will have the remaining of 10 divided by 3. As you know, the remaining would be 1. Let's test it. And as you can see, we have 1 as the final result. These are the basic mathematic operations that we can do on the numbers, and of course we can print the results. But if we wanted to print the results having some message before that, we could do something like this. The result is, for example, but is it possible to concatenate a number to a string? For sure not. And as you can see, it gives you error. It says that int is not a string, so we cannot concatenate them together. But how can we do that? By using str function, which is a pre-built function available for you, you can change result into string, and then you can concatenate it to another string. So now we can have the result is 1. If it was a plus, you could have 13 as a result here. So as you can see, you can change the numbers by using this function str into strings. And of course, when we do operations on the numbers, we know that we can do them even on whole numbers. So if it was, for example, 10.55, and then we wanted to add it to num2, of course we could have the reason 13.55. So you can do all these operations on whole numbers and integer numbers. But there are also some other functions that you can do on the numbers. There are some pre-built libraries that you can implement on the numbers. But what are those? For example, you can have the maximum between some numbers. For example, we want to check the maximum between number 1 and number 2. So we will use the keyword max and then num1, comma, num2. These are the parameters that we can insert into a function, and this function takes the parameters, does some action on them, and returns a value. About functions, you can watch our video in details about how to create your own functions. But now in this tutorial, we're going to talk about the pre-built functions available in Python 3 library. You could even have other values, for example 15, and then the maximum here would be 15, the result. If we didn't have this 15, what is the maximum between num1 and num2? Of course it is 10.55, and you can see the number here. We could even have the minimum number. In this way, if we run this program, you can see 3 is chosen. We could do everything even on the negative numbers. If we take the minimum, you can see minus 10.55 is chosen. We have another pre-built function which is called the absolute value. So for num1, the absolute value of minus 10.55 is, as you can see, 10.55. Of course, for num2, the absolute value is the same, remains 3. We can even mix two functions. For example, we can have the maximum of absolute value of number 1 and number 2. If we wanted to see the maximum between num1 and num2, it was absolutely number 3. But the maximum between absolute values is 10.55, as you can see here. So there are a lot of pre-built functions that you can find on python.org website. You can check them and you can use them if you like. There is also a library called Math Library, on which you also have a lot of functions available, and you can check on Python Math Library to see what capabilities exist for you. In this tutorial, we're going to learn how to get input from the user, how to ask the user to insert something, take that and use that in your program. In order to do that, we'll go through an example. If you want to take an input from the user, first of all, you have to use the function input. And then you have to prompt the user what you want him or her to insert. It is very important to notice that whenever you want the user to do something, you have to notice him. You have to tell him clearly what he is supposed to do. And then the user doesn't mistakenly insert something which is not acceptable. For example, here we want to ask the user to insert his name. So we say, please insert your name. And then we'll wait for the user to insert his name. But what happens after the user inserted his name? We have to put it in a variable. So we will create a variable called, for example, name, and then the output of the function input goes inside the name. So what does this function do? This is a pre-built function in Python 3. It is available for you. You don't need to implement it. It is previously implemented. You only need to call this function. How? Writing the input keyword and then writing the prompt message that you want to tell the user. After this line of code gets executed, the user is prompted with please insert your name, and the cursor waits for the user to insert a name and then press enter. Imagine that you want to take the age of the user as well. So we will write age equals to input, and then we will ask the user how old are you? And then we'll wait for the user to insert his age. I missed a D. Alright. Now we want to print user inputs. So we'll write print. I will say, for example, hello, and then the name. As you remember, you can concatenate these strings together using plus. So hello, and then the name, because we know that this name is a string. Plus, then with \n from the tutorial strings, you remember that \n goes to the next line, and then we write you are, and then we will put the age. Let's run this program. Please insert your name. I will insert my name, and then how old are you? 34. It says hello Reza, you are 34. The important thing to notice is that the output of this function input here is always a string. So the age here is also a string. It is not a number. So you cannot write, for example, age plus 1. If you do, for example, age equals to age plus 1, it will give you an error. Insert the name, Reza, age 34, and then when Python gets to this line, it gives you an error. If you wanted to use this age as a number, you had to change this input into number. How do you do that? With the keyboard int, and then put everything in the parentheses. But what happens behind the scenes? Input, how old are you, gets an input from the user, which is his age, and then returns it as a string. Then this int function gets the return statement which is a string containing a number, and then parses it, changes it into an integer number. So age would be an integer number from now on, and it would be able to add 1 to it. But the problem is that here again it cannot print it because now it is an integer number. So you have to change it again to a string. Now the code works. Write your number, for example, John, and for example he is 44 years old. And now we have to get, hello John, you are 45. Hello John, you are 45. Let's just see what happened again together. We will ask the user to insert his name. Input waits until the user inserts some word and then presses enter. Name as a string is put inside this variable. Then the user is asked to enter his age. Age is a number, but the output of input function is a string. So we change it to number and put it in age. Add 1 to it. And now we want to print everything. If there is a number, we have to change it again to string and write it. In this tutorial, we're going to talk about conditional sentences, or better say, if statements. How can we create conditions in our program? As you know, conditions are very important parts of a program, and in this tutorial, we are going to go in details talking about if statements. Let's come up with a very simple example. Imagine that in your application, you want to force the users to enter only if they are over 18 years old. So the first thing you have to do is to ask about their age. So we'll create a variable called age, and then we will ask the user to enter his age by using the input. So say for example, how old are you? And then we'll wait for the user to insert his age. But as you know, the output of this function is a string, and age is not a string value. We want to change it into numbers, so we have to parse it as an integer number. So we'll write int, and this function int converts the output of this function into an integer number. As you can see now, age is of type int. Now we want to see if the user is over 18, he can enter, else he is not allowed to enter the website. So we use the keyword if, and then we will write our condition here. Condition is very important. Take care about the way you write the conditions. In the operators tutorial, we will talk about different types of logical operators here, because here you need a logical operator. But in this tutorial, we will talk about a very simple condition. If age is greater or equal to 18, colon, we will come to the next line, and then we will write the code that we want to execute. For example, here we want to let the user enter. As a very short example, we will just print welcome. But if the user is less than 18, he has to be informed in some way. So we say else, if he is not 18, or better say else, we will print for the user, for example, sorry, you are not allowed to enter. And that's all. But let's see how this if statement and else statement works. If checks a condition. In the condition for the numbers, we have different types of comparisons. If we want to see if something is equal to something, we will use this one as equal. Why? Because a single equal sign is the assignment operator. If we write only one equal, it means that we want to assign something into other things. But if we want to check the equality, we have to use two equal signs. If we want to see if something is not equal, we will use this sign. Greater we use this one, greater or equal, less than or equal. These are the operators that we use in order to compare two values. They are called comparison operators. Now we used this one, which is this one. And then we use the column. Whatever comes after column is related to this if statement. And it means that whatever comes after this column will be executed if this condition exists. But this else is also after this column. How do we understand? How do we choose a scope for this if statement? By using indented statements. We have to indent everything that we want to write inside this scope. For example, if you wanted to write welcome and then you wanted to do something else, you will write, for example, you are over 18. Both of these sentences are related to this condition. And then if you want to write something out of the scope of this, you have to finish the indentation. You can have else or you can ignore it. So in this way also our application works, but it is a good idea to inform the user about what we intend to do. So it is better to tell the user that you're not allowed to enter the website. And then after this column, again, whatever you write is in the scope of this else, unless you finish the indentation. For example, we'll print end. Here the program finishes. So because there is no indentation related to this one or this one, this end is executed in any case. This part is not important. It is out of the scope of this if and else. Let's run our program to see what happens. How old are you? We will enter, for example, 17. It writes, sorry, you are not allowed to enter end. So it checked 17 is more than or equal 18. No, it goes to else, enters the block, writes whatever is inside the else block, and then ends the program. Let's run it again. And here for the age we use, for example, 25. And then if we press enter, it says welcome, you are over 18. And what happened? Age is 25. It is greater or equal than 18, so it enters this scope. Writes welcome, you are over 18. Doesn't execute this part because it is only the else situation, and then ends the program. In this tutorial, we're going to talk about operators in Python programming language. But what are the operators? We've got four main types of operators. The first type of operators in Python is the math operators. But what are mathematical or math operators? We have got a variable called num1, and imagine it is 10. Then we have got num2 with the value 5. Then we have got the result variable, which is going to contain the result of some mathematical operations. For example, num1 plus 8. This plus here is a mathematical operator. We could do num1 plus num2 or whatever. There can be a constant value or there can be a variable here. The other mathematical operator is minus. num1 minus num2. We can have multiplication sign, num1 multiplied by num2. We can have the division. We can have the ceiling value of division, which is, for example, if this was 3, 10 divided by 3 is 3.3333 and so on. But if we use this sign, 10 divided by 3 just returns you a 3. And then we have got the remaining. of a division. We talked about them in details in the tutorial related to numbers. You can find detailed information about mathematical operators in that tutorial. The other type of operators are assignment operators. But what are assignment operators? The first and most important one is this sign equal. How do we use it? As you remember, for example, you have got a variable called age, and then you want to assign a value to that variable. For example, 48. So you assign this number into this variable using the assignment operator. But assignment operators are not only equal, there are more. You can do something like age plus equal 5. And what does it do? This line is exactly the same as writing age equals to age plus 5. It adds 5 to age and again puts it in the age variable. So if at first age is 48, by executing this line of code, age gets 53 because it adds 5 to 48 and then puts it again inside age, like here. Adds 5 to the age, puts it again inside, assigns it again to variable age. The same way, we could have minus equal, which decreases 5 from age and then puts inside age. Then we can have multiplication, we could have division, we could have remaining, we could have all mathematical operations together with assignment. And it is a short form of writing something like age equals to age remaining, for example, here 5. And these are called assignment operators. The other type of operator is called comparison operators. We talked about comparison operators in the if statements, in the conditional statements. What are comparison operators? They are equals when you want to check if two variables or two values are equal, not equal, greater than or equal to, less than or equal to. And as you remember, if you wanted to use them, for example, you could use them in if statements. For example, you could write if name is John, then do something. And then you remember you could write else, do something else. And you remember the scope of if is all the indented statements that come after this column. Of course, the scope of else the same. The last type of operators that we are going to talk about today is the logical operators. Logical operators are and, or, and not. We have got 3 logical operators. But how do we use these logical operators? For this, we will go in details with an example. In this example, we'll try to use all the operators we talked about in this tutorial. Imagine that you have an application, and in your application, first of all, you ask the user to insert some information. For example, you want to know the name of the user, then you have to ask him, please insert your name. Then another information which is important for your application is the user's age. You will do the same. You will ask the user, how old are you? And then you'll wait for the user to insert his age. And you are sure that the output of this function is always a string and age is a number. And it is usually an integer number. So we will convert it to an integer number like this. Now in the application, we want to see if user's name is John, you are not going to allow the user to enter your application. So we'll write if name equals to John. You will say, for example, you are not allowed to enter. I don't know why, maybe you have got problems with a John. So if the user is John, you don't let him enter your website. But imagine that you have got another condition for the users to enter your application. So if they are not John, else you want to put another condition. If, and instead of writing else if, you can write elif. This is a keyword in Python that you can use it. What does it mean? It means if this one is not true, then we want to check another condition. So else if, and now you want to have another condition. You want to see if the user's name is Alex and he is less than 18, again he cannot enter your website. But you want to print, for example, something else. You say, sorry, you have to wait until you get 18, like this. So in our program we have used a comparison operator with equals, and we checked if user's name is John, he cannot enter. So if the user's name is not John for sure, we want to check another condition. If the user's name is Alex and he is less than 18, we are not going to allow him in. This and means that both of these conditions should be satisfied if we want to enter the block after this column. So if either of these is not correct, we don't enter here. So if the user's name is, for example, Mary, for sure it doesn't enter here, even if he is less than 18. Or if the user's name is Alex, but he is 25, again, we never execute this line of code. And if the user's name was Mary and he was 25, for sure, we will never execute this code. So if we have got and, it means that both of these conditions should be satisfied if we want to enter. So far, if the user's name is John, for sure we will write this for the user and then we will exit the application. If the user's name is not John, we will check another condition. If his name is Alex and he is less than 18, we will print this information to the user. We want to check the last condition, and for sure you know that you have to get out of the scope of this elif. So we'll go to the start of the line, elif. We want to check if user's name is not Jack or he is greater than or equal to 85, we will print you are not suitable for our application, whatever. So what are we checking here? We say if the user's name is not Jack, he will enter here. So we like only Jacks. If it is not Jack, we will enter here. But we will put another condition. If he is not Jack, maybe he is over 85. If he is also over 85, he will enter here. So we will check two conditions. If either of these or both of them are true, we will enter here. So if the user's name is, for example, Jonathan, this is okay, and then we will enter here. It even doesn't read this one. If the user's name is Jack, so this one is not satisfied, it will look here. And user is 55 years old, this one is not satisfied, so we will never enter here. Either of these should be satisfied. And then finally we want to say else. You will say, for example, welcome. So it is very difficult to enter your website. Let's run the program to see how this and or these conditions and these assignments work. Please insert your name. The first case, imagine that my name is John. It asks how old are you, no matter, for example 67. We are sure that it says you are not allowed to enter because my name is John. So if it is John, you are not allowed to enter, and then the program finishes. It doesn't enter any of these anymore. Let's run again and check with another condition. What is your name? We will check Alex. How old are you? 17. So this line of code is not satisfied, so we will never enter the block here. This line of code is only satisfied if both of these sides are correct. The name is Alex, so this one is correct. Then age is less than 18. This one is also correct, so we are waiting for this line to appear. Let's see. Yes, sorry, you have to wait until you get 18. Let's run it again, and this time let's check with Tom. The name is Tom and he is 23. Let's see what happens. The name is not John, so never here. The name is not Alex, and because we have got and, we'll never read this part anymore because both of them should be correct. When the first one is not correct, it doesn't read here. It comes here. The name is Tom. The name is not Jack. So for sure we will enter here. It doesn't look even at the age because for or either of these is enough. Name is not Jack, so he is not allowed. You are not suitable for our application. Let's run again the application, and this time let's name him Jack and imagine that he is 70 years old. Let's see. His name is Jack, so this is not satisfied. This one is not also satisfied. Let's come here. The name is not Jack, so this is not satisfied, but we have to also wait for here. If this one is satisfied, we will enter again. Age is greater than or equal to 85. Is it? No. So none of these are true. So this condition also is not satisfied. We will not enter here and we will end up here welcome. So I am Jack and I am less than 85. I can enter. We could change this line by writing not and then in the parentheses name equal to Jack. It is the same as writing name not equals to Jack. Not is the reverse. So we are sure that with Jack and 70 we will never enter here. Let's check again. With Jack and 70 we say again welcome. So we will never enter here because the name is Jack, so the not of this one is false. This is true. The not of this one is false, or this one is also false because it is less than 85. So false or false is always false. Just try to remember true and true is true. True and false is always false. Even if this false was here, the side is not important. So false and true is always false. And lastly, false and false is always false. So the only way that and gets true is that both sides of and should be true. On the other hand, I will just copy everything and try to show you what exists for or. True or true is always true. True or false is also true. False or true is also true. So if either side is true, it is true. False or false is always false because there is no true to get back. You have to remember these in order to use logical operators. and logical operators always return true or false. In this tutorial, we're going to talk about data structures in Python. And there are different types of data structures in order to store sets of data. But today we're going to talk about the most useful one, which is the lists. But what are the lists? Imagine that you have a set of values and you want to store them. As you know, the primitive types like string, like numbers or booleans cannot contain a set of values, but you can store a collection, a set inside data structures like list. But how do we do that? Imagine that we have got a list of colors. We'll have a variable called colors inside which we want to have a set of colors. First of all, the important syntax for the lists is the brackets. You have to use the brackets. And because the colors are string, so all the values inside are of type string. Imagine that the colors are red, we have green, maybe blue, and black. Let's add another color, for example, white, because when we want to talk about indices, we will need at least 5 values to be more clear and precise. Alright, now we have got a set of colors in a variable. How can we access these colors? First of all, imagine that we have got a print and we want to print everything inside the colors. We can simply say print colors, and if we print this one, it will show us the whole list. As you see here, colors is of type list of strings, a list that contains a set of string values. Of course, you could have different types, different values inside. For example, here you could have number, or here you could have a boolean type like true. Then it would give you a list of different types, string, integer, and boolean. But it is better to keep the items inside the list of the same type. So we'll just reverse everything. And if we run this program, it will print you all the values inside the color. As you can see, red, green, blue, black, and white. But what if we wanted to get access to each item? Like the strings that I told you, they have index for accessing each value. Here also we have got indices. Red is index 0. Green is index 1. So be careful, indices always start with 0. Blue is 2, black is 3, and white is for sure 4. So if you want to access these values, you can address them using the indices. So clearly, if we want to see red, we can write like this: colors, brackets, and then 0 inside. As you can see, red is printed here for us. If we put 3, we could have black: 0, 1, 2, and 3. If we have a very long list and we don't want to count from start, the last index is always -1. So you could access white using colors of -1. So if we run this program, we can see white here. So clearly -2 is black, -3 is blue, -4 is green. For testing, you can see -4 is green. So you can access them starting from 0 for the first item, 0, 1, 2, 3, 4, or you can access them using minus numbers, -1, which is the last item inside the list, and so on. You can also access a range of items using column. For example, you want to access 1, 2, 4, but you have to be careful about the last one. If you write 4 here, it will start from the first index, which is 1, then it goes 2, 3, and it doesn't include the last one. So from 1 to 4, it shows you 1, 2, 3. This is 0, so it is ignored. 1, 2, and 3. Let's run it. You can see green, blue, and black, which are these. You could write 1, 2, 3. You can say green and blue are printed here. You could say 1 to minus 1. You know, minus 1 is this one, but this one is not going to be printed because we will go on until the one before the last. So we will have green, blue, black here, up to black, because white is not considered. So from, for example, 0 to minus 3, we'll get, this is 0, and minus 1, minus 2, minus 3. So this one is not also included. It is red and green, as you can see here. But if you want to start from 0, you can leave it empty here. So the left side of column can be empty, and if you leave it empty, it means from the start. So it will give us the same results, as you can see, red and green. Or you can start from 1 and you can leave the last one empty. Let's see what happens here. Green, blue, black, and white. So it says that starting from this index, go until the end, even containing the last item. So this is the way to access the last item if you leave it empty here. This was the way to get access to multiple values inside a list. You can give values and change the values of these by accessing their index. For example, you can change color 1 to maybe gray. In this way, if you run this code, it will start from gray, not from green, because color 1 is gray, not green anymore. As you can see, if we print all colors, you can see that green is replaced with gray. You could also give value to a set of values. For example, from 1 to 4, which is 1, 2, and 3. 3 items. And we want to put gray for all of them. So we'll write like this. Gray, and then again, gray. So what happens here? From 1 to 4, it means from green, 1, 2, and 3. These 3 will get gray. And when we print all the colors, we have red, gray, 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 and white. Let's check. As you see, red, gray, 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 and white. There are also some pre-built functions that you can apply on the list. For example, you can see how many items are there in a list by using the function len and then putting inside the parentheses as the input parameter the colors. So you will get the length of this color. Here it should be 5 because there are 5 elements in the color. Let's see. As you can see, there are 5 elements in this list. The other thing that you can do is you can delete one item. For example, you can say del and then colors 2. What is colors 2? It is blue. If you write this and then we see the length, it will be 4, as you can see. And then if you want to see the colors only, you can see that blue doesn't exist anymore. Let's check. As you see, red, green, black, and white. Another thing you can do is you can extend a list. But how can you do that? You can do, for example, colors dot extend and then a set. For example, gray and pink. What does it do? It adds these two, or it adds this other list to the end of the colors list. So colors would be red, green, blue, black, white, gray, and pink. Let's check. As you can see, gray and pink are added to the end of colors. You could put that in a variable called, for example, list, and then you could add this list to extend here. If we run it, you can see the same results. So you could put this one directly here, or you could put it inside a list and then add it here. The other thing you could do is that you can append one value at the end of the list. You can use append function, and then you could add one element, for example, pink. So if we print colors, we will have red, green, blue, black, white, and pink also at the end. As you can see, pink is added after white. But append and extend added the item to the end of the list. What if we wanted to add something to the first, or we wanted to add something in the middle? That's doable by using insert. But what does it take as input parameters? First, it gets the index. For example, you want to add gray between red and green. So the index would be 1. This is 0, and after 0 is 1. So you'll put 1 as the index, and then you will put the value, which is gray. Let's run it. As you can see, gray is added here. You could put it at first. You see, gray is put at first, and then all the list is put after that. So you can set the index here, and then if you set an index, it will shift the others coming at this index and afterwards one to the right. You could also remove a value. As you remember, by deleting, you had to say the index. But imagine that you want to remove green from your list, but you don't know where green is. So you will write remove, and then you will write only what you want to remove. Here you want to remove green, so you will just write remove and then green. As you can see, green is not in the list anymore. What if you had two greens? Lists can have repetitive values. There is no problem for them. Let's check if we had two greens, what happens. As you can see, the last green is remained. So remove starts from index 0, goes on, and it will remove the first occurrence of a value. And then it gets out of this function. So it removes only the first green. You could get access to the index of each element. For example, you want to see what index blue is in. So you could write index and then write whatever value you are searching for. And then imagine that we want to print this one. Here we are supposed to get 2. As you can see, 2 is printed here. So you can get access to the index of a value by using function index. Now we have got 2 greens here. If we wanted to count how many greens are there in this list, you could just use the function count. So it gives you 2. So if you counted blue, we know that 1 is going to be returned. So we can count the number of occurrences of a value. The other thing you could do is that you could clear a whole list. Colors dot clear, and then colors would be an empty list. As you can see here, color is empty. But what is the difference between colors that clear and del colors. Del colors would delete this variable. So when you delete a variable and then you call it, it doesn't exist anymore. So it will give us an error here. As you can see here, it says name colors is not defined, because when you delete a variable, Python doesn't understand this color anymore. So if you want to clear a variable but later on use that variable inside your application, it is better to clear it, not to delete a variable. As you see, it is an empty list. You could also sort everything inside the list. For primitive types like numbers and strings, there is a pre-built library called sort that sort them. If they are numbers, it will sort them normally. If it is a list of strings, it will sort them alphabetically. So you can use list.sort, and then if we print color, you can see that they are sorted. BLA, BLU, GR, both greens are the same, red and whites. But imagine that you needed the sorted value, but you didn't want to change these colors. What should we do here? We want the sorted value, but inside another variable, we don't want to touch this one. So we could write, for example, list2 equals to sorted of colors. And then if we print colors and then after that we print sorted2, you can see that colors is the same as you see here, but list2 is the sorted version of colors. The last thing we are going to talk about here is checking whether something exists in the list. How do we do that? We can say, for example, red in colors. It will check if red is in colors. If it exists, it will return true. If not, it returns false. Let's see. Now we are waiting for true. If it was misspelled, it would return false. There are other pre-built functions on the list that you can check them on python.org, but I think the ones that we talked about are the most useful ones. Be careful that lists are one of the most powerful data structures available in Python. Try to make different types of lists, play with them, and learn how to store sets and collections of variables inside lists. If you have got any question, please ask me under this video. I will answer you as soon as possible. And if you like this video, please subscribe to our channel and gives us thumbs up. In this tutorial, we're going to talk about another data structure called tuples. In the last session, we talked about lists, which is one of the most useful data structures in Python. If you've got any question, you can refer to that video. In that video, we talked a lot about putting a collection of data inside one variable called lists. In this session, we'll talk about tuples. Tuples are a little bit different from lists, and the reason is that tuples are immutable. You cannot modify something inside a tuple, or you cannot add or remove items inside a tuple when they are created. Let's go through some examples to see what tuples look like. Imagine that we have got a shopping list, so we will call our tuple as shopping list. And then imagine that inside our shopping list we have got 3 different items. In lists we use brackets, but in tuples we use parentheses, open and close parentheses, and inside that imagine that we have got 3 different strings like milk and maybe butter, and lastly maybe bread. Now we've got a tuple with 3 different items. You can print whatever inside this tuple, like we did in the lists. If we run this program now, you can see whatever inside this tuple, of course showing with open and close parentheses, which shows that it is a tuple. You can also access the elements inside the tuple. For example, shopping list 0, you know the index starts from 0, so this is index 0, index 1, and index 2. Shopping list 0, we are waiting for milk to be printed on the screen. As you can see, milk is printed. The same as in the list, you can access to the last item by using -1. And as you can see, bread is printed here. So obviously -2 is butter. And of course, 0 and 1. If we start from 0, index 1 is also butter here. So we can start from the first item by index 0, 1 and 2, go on, or we can start from the last index, which is bread here, which is -1, and come back. You could also, like the list, you could access to a set of items with column. For example, we want to see 0 to 2. This is 0, 1, and be careful, the last one is excluded. So if we write from 0 to 2, it means 0 and 1. Let's see the results. As you can see, milk and butter are shown. If we didn't put this one, it means starting from the first item up to index 2, which is here 0 and 1. So we'll have the same results here. And if you write something here like 1 and then you put nothing here, it means up to the end. So here we'll have butter and bread together, like this. So we can determine the start and end indices here. All the functions that you had on the list are also on the tuples. For example, you can have the length of the tuple using len function, and here it is 3, so you will have 3 as the length of this tuple. But as you remember, the functions regarding adding or modifying items inside lists are not applicable anymore. So you cannot write, for example, shopping list dot append. If you write app, it doesn't suggest you append. And if you write append and add, for example, water to it, it gives you error. It says that tuple object has no attribute called append. You cannot append something. Obviously, extend also doesn't exist. As you see, it doesn't suggest you extend. Even you cannot add anything using the index. As you remember, in the list, if it was a list, you could change the value of an item to, for example, water. But here you cannot modify it. It gives you an error saying tuple object does not support item assignment. If we only change this one to open and close brackets, it will allow you now, and it will show you, of course, the length. We will remove this one also to see the final result, and you can see that butter is replaced with water. But tuples are immutable. Just open and close parentheses tells the application that it is a tuple. As you can see, tuple with 3 strings inside. And of course, as you remember, you can have different data types here, and they are immutable. You cannot modify elements inside a tuple. You cannot add or remove items from a tuple. You can remove all the tuple by deleting that, but you cannot add or remove items. They are immutable. So if you have got a data structure for which you don't want to change anything, and you want to give values at first and never change them again, tuple is the best data structure. But if you have got a dynamic data structure on which you want to modify some elements, add items, remove items, lists are one of the choices. Of course, you've got other types of data structures like sets, like dictionaries, and so on. Knowing lists, tuples, and dictionaries, you are able to write most of your programs. In this tutorial, we're going to talk about functions. But what are functions and when do we use them? Functions are a way of making your program more organized and neat. You can prevent rewriting some parts of your code using some functions. You can encapsulate some parts of your code inside a function, and just calling the name of that function will execute that part of your code in your whole program. So imagine that you want to do some action in different parts of program and you don't want to repeat the same part of code. The best way is to have a function, and using functions you can write your code once and call it as many times as you like. But how can we define a function? In order to create a function in Python, you have to use the keyword def. And then after that you will write the name of your function. Imagine that we have got a very simple function where we want to just print hello for the user. The name of a function is, for example, say hello. We use the naming convention in Python where we always use lowercase, and when we have compound nouns we use underscore. Then we have got open and close parentheses and then colon. This is a syntax for a function. And then whatever you want your function to do should be written here but indented. It is very important. Everything you want your function to do must be written after this colon but indented. For example, we want to print for the user hello there, and then you want to do something else. You want to print how are you. As you can see, both of these lines are indented, so it means that both of them exist in this function's scope. If you go to the start of the next line, it means that you are outside this function. Now if we run the program, we will see nothing. As you can see here, nothing is printed for the user because we have determined a function but we have never used it. It is like you say, I have a hammer, finished, but you don't use this hammer. You have to go to your closet, take this hammer and try to use it. So functions are like devices. Functions are like machines. They will do something for you, but first of all you have to turn them on. How do we use functions in our program? Let's see. In your main program, maybe you want to first of all print a bunch of equal signs for starting and ending your program, and then inside that you want to execute some code. For example, you want to tell the user hello there, how are you? What do? You will call the function say hello, and that's enough. When you call the function, Python finds it, goes inside the body, executes that, and then ends up. So our program starts from here, prints some equal signs, then calls this function. Inside this function we will print these two sentences, and then we will get out of the function. The next line is printing some equal signs and finish. Let's run the program. As you can see, we have got equals, hello there, how are you, and then equal signs. But this type of function is one of the simplest kinds, where there is no input parameter and it doesn't give you back anything. It just prints something on the string. Imagine that you know the name of the user and you want to say hello to that user. So here we will pass the name of the user as an input argument, and then we will write, for example, hello, and then the name. We will connect this name to this hello. So here we are expecting hello, the name. But if we call this function without any names, it will give you an error. So you have to provide a name to the user. You can provide it here, for example, John, or you can determine a variable, for example, name equals to Alex, and then you can call this name here. Something very important here is that this name shouldn't be exactly the same as this one. It is not important for the program. So you could here write, for example, first name, and then you will call, say hello with first name. When you call this one with first name, Python comes here and sees that, okay, I am asking for one input parameter and he has given a parameter. I will put that variable inside my local instance, which is name here, and then I will go on continue with this name inside my scope. So here we are waiting for equal signs, then this part just gives a variable some value. Then we enter the hello function. It will print hello Alex, how are you, and then equal signs again. Let's run the program to see the results. As you can see, hello Alex, how are you. You could have even two different arguments, two different input parameters. For example, you could have also age, and then here maybe first name, and as age you will write 25. Here you can say print hello whatever you are plus age. So it should print you are 25. Let's run the program. Hello Alex, you are 25. But what if this 25 was a number like this? As you know, you cannot concatenate the numbers to strings, so you have to change this one to string by using str function, and then you can have everything. As you can see, hello Alex, you are 25. But I said str function. Yes, that's it. These are the functions that we write, but of course there are some pre-built functions inside the Python library, which is here. As you can see, Python 3.8, you can use all the libraries that Python has provided to you. And now you remember that we had some functions in the tutorial. We talked about lists and strings, and we said that there are some pre-built functions inside Python. You could use them. These are the functions that are determined like this. So far we have talked about the functions with no parameter, with two parameters, with one parameter. But what if we have a function that returns a value, does some actions, and gives us back a value? We will determine those functions like this. Imagine that we have got another function. We say def. The function is, for example, add numbers. And maybe we get two numbers, num1 and num2, column, don't forget this column. And what do? We create another variable called c, and we say num1 plus num2. And then what do? We use a keyword named return, and then we return c. What does this function do? It gets two input parameters, adds them, and puts the result in another variable called c, and then returns this c. But how can we use this function? Let's just make it a little bit bigger. Okay, imagine that we want to use that here. For example, number 1 is 25 and number 2 is 30. Then we call add numbers, and then we give number 1 and number 2 as input parameters. But then it returns c, so we will have another variable called, for example, result, and then we put it equal to the return value of this function. Python enters from here, understands that there are two functions, but it doesn't run them because they are not called. Comes here, prints some equal signs, gives 25 to number 1, gives 30 to number 2, computes the result, which is the output of this function, the return of this function. What does this function do? Adds two numbers and return the results. Takes the results and puts it inside this variable. You can call it whatever you like. Then we want to print results. Let's run the program now. As you can see, 55 is returned, which is the summation of these two numbers. You could directly pass two numbers here. For example, 20 and -5. So we are waiting for 15 to be printed here. As you can see, 15 is returned. So we have got different types of functions. Function with input arguments, functions without input arguments or parameters, functions with return types, or functions without return types. In this tutorial, we talked about all different types of functions. They are used in order not to repeat a part of code many times inside your program. So if you have got a part of code that you are sure that you will repeat that in different parts of your program, it is a good idea to write them in functions and just call the function. So instead of writing all the lines of that function, you just call the function. It is only one line of code. But there are also some other benefits behind the functions, and that is to organize your code. It is not a good idea to write all your code inside one function inside the main program and then write all the logic behind your code line by line. It is better to organize your file. Maybe you can put these functions inside different files to make this file smaller, and the reader can read your code, and even you can read your code and debug your code easier. You can put them inside different files and then use those files here. In this tutorial, we're going to talk about loops. And loops are very useful in Python because if you want to repeat an action for a specific number of times, it is not a good idea to rewrite the code. We have to use loops in Python in order to repeat actions. One of the most famous loops in Python are while loops. And today we're going to go in details talking about while loops, and we will design a guessing game that user 1 has to determine a number and user 2 guesses the number. But first of all, let's see what while loops look like. One way to implement while loops is to have a counter. Imagine that we have a variable called I and we start the value with 0. And then inside our program, we want to add numbers to y and print them 5 times. So we will write while I is less than 5, colon. Then we will enter the scope of while. You remember that it has to be indented. Then we will say, for example, print I. And after that, add 1 to I. It is an assignment operation. I plus equals 1 means I equals to I plus 1. This is the same. What does our program do? First of all, it gives 0 to I. Then enters this while loop. Checks the condition here. This is the condition part of the while loop. It checks if while is less than 5, enters the loop, prints I, and adds 1 to I. Now I is 1. Is I less than 5? Yes. Prints I gets 2. 2 is less, 3. 3 is less, 4. 4 is less, 5. 5 is not less than 5, so it gets out of this while loop, and whatever we have here outside, it will print that. For example, we'll write print end. If we run this program, as you can see, it prints 0, 1, 2, 3, 4, and end finally. So we have entered this while loop 5 times. But this was a very simple example of how while loops work. They need a condition here. While the condition is satisfied, we enter the while loop. But now we want to write a very nice program which is a guessing number. In our guessing number, we have got two players. Player 1 inserts a number, and then player 2 must guess the number. The number must be from 1 to 50, and player 2 has only 5 guesses to get to the number. You remember that we get the numbers by using input. We call the variable as answer because this is the answer to our guess number game. And we write input, and then we prompt player 1, please insert a number. And then we have to clearly inform the user that your number must be from 1 to 50. Then we wait for the user to enter the number. But guess what happens if you run this program? As you can see, player 1 enters his number and player 2 will see the number. So in this tutorial, we are not going to use input. We are using one of the pre-built libraries that doesn't show a character. And as you have already guessed, when we want to enter password, we don't want the others to see our password. So there is a pre-built library. We use it from getPass. As you can see, it suggests to you. This is a pre-built library in Python. We want to import the function getPass. So when we say from, it means from this library, import to our program this function getPass. And then now we use this function. So we say getPass player 1, please insert a number from 1 to 50. Now if the user inserts something, we don't see that on the screen. But PyCharm, in order to understand it, it has to mimic the console application. So don't forget to go to the Run menu, Edit Configuration, and just check this one. Emulate terminal in output console. You have to emulate a terminal. Now if we run our program, it asks for a number. Now I am writing things, but it doesn't show anything. And when I press enter, it ends up. So our application works, and we can enter numbers without user 2 to understand what the number was. Since our number must be an integer number and getPass, like input function, returns a string, we have to convert it. So answer equals to int. We want to convert string to int, and again answer. So now answer contains an integer number. Now player 1 has inserted a number. It is time for player 2 to make guesses. He has 5 guesses to reach this number. But in order to count these guesses, we need a variable. So we will call it try_count, and we will start it with 0. This variable counts the number of times that the user guesses. And then we need another variable to understand when the user has finally reached the number, found out the number. So we'll call it, for example, is correct. And because the user hasn't understood it yet, we will start it with false. We have set all the variables. Let's create a while loop. But what is the condition that we get out of this while loop and finish the game? There are 2 conditions. First, if the number of guesses is more than or equal to 5. So if try_count is less than 5, we will continue. If not, we will get out. So one of the conditions that we go inside this while loop and ask for the user to guess a number is that the try_count is not still 5, 0, 1, 2, 3, 4. And because both of these conditions should be satisfied. The other condition is that the user has not guessed correctly the number. So is correct is still false. I will repeat whatever I did here. We want to ask player 2 to guess his numbers, and we want to repeat this action. But how many times? While the number of guesses is less than or equal to 5, because we start from 0, we will write less than 5. And the user hasn't reached the final number. With these two conditions, we will go inside our while loop. But what do we want to do? We want to have a variable called, for example, user's guess, and then we want to ask the user to insert a number. So we'll use input, and then we say player 2 guess a number. And now we'll wait for the user to insert his number. As you remember, input returns a string value. So we can here convert this string to an integer number. So input gets out the string value of what user has inserted. We will change it into a number and we'll put in this variable. Now guess contains user's guesses. And now we have to check if the user has guessed correctly or not. We will come here, if, and be careful, we are still inside the while loop because we are writing indented, and every iteration of this while loop will execute all of the lines inside here. If answer equals to guess, what do we do? If the answer is correct, we will print to the user player 2 you won, because player 2 has guessed correctly. But if we finish it up here, it will enter and ask again. So we will set this is correct to true, because we don't want this while loop to be repeated again. This was for the first condition. But else if, elif, you remember in the if statements, else if answer is greater than guess, we want to inform the user that the answer is greater than, and then the number that user inserted, which was guess. We have to change it to string guess. Now what we have to do, because we are letting the user to guess another time, we have to increase this try count, because one guess is done. So try count plus equals to 1. So far we have covered if answer is equal to guess, if answer is greater than guess, and finally we have to cover the last condition, which is answer is less than guess. We'll just write else, because this is the only other possible solution. If this one and this one are not satisfied, for sure answer is less than guess. I will copy these two lines and paste here. Only I will say answer is less than guess, and then we will increase try count. It is important to notice that in each iteration only one of these three will be executed. If it is equal, this one gets executed. If it is more than guess, this one and this one. So we will repeat it until this try count reached 5. If it gets 5, we will get out. It means that the user has guessed 5 times. Or until this is correct, gets true here. If the user answers correctly, we will inform him. But what if the user hasn't answered correctly and we have reached 5? So when the application ends up here, we will check if is correct equals to false. It means that we have gotten out of this while loop, not for this reason, but for this reason. If is correct is still false, it means user won, has won the game. So we'll just print this line and change this one to 1. So here we are sure that user 1 has won the game and the game is finished. Let's trace all the program together. First, we have imported getPass because we didn't want the number that user 1 inserts be seen by second player. So we imported getPass from library getPass, and then we ask user 1 to insert his number from 1 to 50. We transform this number from string to integer. Then we declare two variables, one for counting the number of guesses that the user makes, and the other one for checking whether the user has guessed correctly. And then we enter a while loop. We will ask the user to guess, and guess, but if the user guesses 5 times, we will get out. We are not going to let him guess anymore. Or if the user guessed correctly, again we will get out and then we will exit the program. But inside each guess, what do we do? First, we ask the user to guess a number. We will check this number with the answer that user 1 inserted. If it is equal, we prompt the user, you are correct, and we set this one to correct so the next time it doesn't enter and the program finishes. If the answer is greater, we will inform the user so that the user can guess the next time more precisely. And finally, if the answer is less than guess, we will again prompt the user. For both these cases, we will add 1 guess to the count of guesses so that if we reach 5, we get out. But if we get out, if the user has answered correctly and has gotten out for this reason, it means is correct, is true, we will check. We will do nothing because we have prompted the users, the players, that player 2 has won. But if we get out of this while loop because this try count has reached 5, it means that user 1 has won the game. We have to prompt the user. So this one is false. User 1 has won the game. Let's run the program and play. User 1 has to guess a number. I will insert a number, maybe 35, but you cannot see this. But the entered number was 35. Now player 2 has to guess a number. He will guess, for example, 24. Answer is more than 24. The user inserts, for example, 46. Answer is less than 46. So the user knows it is between 24 and 46. So the user may insert 30. Answer is more than 30. The user inserts 38. Say answer is less than 38. The user inserts 36. It is not correct and the game is finished. So player 1 won the game. Let's play it once more. Insert a number, for example 25. User 1 guesses 40, less than 40, 30, less than 30, 20, more than 20. Maybe by chance the user inserts exactly 25. Player 2, you won. So this is a guessing number. I hope you have enjoyed this program and you have learned how to work with while loops, if statements, conditions, how to set flags like is correct, and how to set counters in your program. I hope you have learned how to import pre-built libraries inside Python and to get passwords or the things that you don't want the user to see from the input. In this tutorial, we're going to talk about for loops. For loops are a type of loops that we usually apply on the lists and on the collections of data. Of course, there are many other use cases of for loop. Today, we are going to talk about different ways you can use for loops. The first and simplest way is to loop over list items. Imagine that you have got a shopping list on which you may have butter, bread, and maybe milk. And you want to print items inside this list one by one in separate lines. The best way is to use for loops. But what is a syntax? We write the keyword for, and then we determine a variable that at each iteration of the for loop takes the value. We can call it item, element, whatever you like. The name is not important. In, it says in which collection, and then you have to write the name of the list, which is shopping list here. For each item in the shopping list, what do we want to do? We put a column, then indented, because we are in the scope of this for loop, we will print item. Because item is a string, the list is a string, we don't need to convert it. So if we run this program now, it will fill shopping list here, and then item by item, it goes and reads shopping list, put the item inside this variable, and then prints it. And then when the list ends up, this for loop also ends up, and then the program finishes. Let's run this program to see the results. As you can see, butter, bread, and milk. In order to see another use case of for loop, we will consider phrase. As you remember, phrases are a collection of characters. So maybe we have got a phrase like Vision Academy tutorials, and in this phrase we want to count, for example, letter I's or letter A's. We want to see how many letter I's are there. So we need a counter. We set the initial value to 0, and then you see for each item in phrase, we want to check that item. If item equals to, for example, I, we want this counter to be incremented. And then finally, we will print counter. Let's trace our code. First of all, we have determined the phrase, Vision Academy tutorials, and then we have set a counter to 0. For each character in phrase, if you write this on a string, it loops over the characters one by one. And of course, it is case sensitive. So if we had capital I, it wouldn't count here. It checks each character. You remember this item can be everything. You can put it as letter. So here also, we have to change it as letter. It can be whatever, not important the name, but you have to call the same name that you put here inside the body of your for loop. So if letter is I, we will increase the counter, and finally when the letters inside phrase ends up, we will get out of this for loop, and here you can see that the counter is printed. In Vision Academy tutorials, we have got 1 I, 2 and 3 I's, so we are waiting for 3 to be printed. As you can see, if we check, for example, A, we will see 2 A's because this A is capital and it is not counted. Only this one and this one are the ones considered here. Now let's talk about another interesting example. You can design functions and use the functions inside your program. As you remember in our course functions, we talked about how to define a function. We want to define power function to get a number to a power. We'll write def in order to write a function, and then we call our function power function. And then as the input, we want 2 numbers, the base number and the power. And what does this function do? It wants to get that base to the power. How do we do that? We determine a variable called, for example, results. We set it to 1, and then we say for I in this I is the variable, it can be whatever. Now we want to iterate and multiply this base power times. So if power is 3, we want to do this 3 times. If power is 5, we want to do these actions 5 times. So there is a function in Python called range, and then in this range you determine the number of times you want to repeat that. With the range power, what do we want to do? We want to multiply result by base. First result is 1. The first time that we iterate here, don't forget the column. So imagine that base is 2 and power is 3. Range 3 is 0, 1, and 2. But we are not working with I. I is not important for us. We just wanted the repetition, the number of times that this for loop is going to be repeated. So base is 2, power is 3. Range power is 0, 1, 2. For 0, we will multiply result by base. Base is 2, result is 1. 1 multiplied by 2, 2. Then I gets 1, the value of I is not important. 2 multiplied by 2, 4. I gets 2, this result is 4. 4 multiplied by 2, which is the base, it gets 8. I finishes, because range it was 0, 1, 2, range finished, and now result has the final value. What do we want to do now? We will return result. How do we call this? For example, we call this like this. Power function, two numbers, 2 and maybe 3. We will print what this function returns for us. And this function calculates the power and returns the value. Let's check it. 8 is returned here. If we wanted to see power 4 of number 3, we could easily calculate this. It is 81. We can see power 2 of 10, which we're sure it is 100. You can see the results here. So range creates a range of numbers for you. What is there inside range? We can print the values of range here, which is I. Let's see. 0, 1, and then finally the result. Because it was 2, power 2, range of 2 is 0 and 1. If we called it with power 4, we are waiting for 0, 1, 2, 3. 0, 1, 2, 3. And finally the result is printed, which is this result. Range can be called in another way. For example, we could call range of 1 to power. Now, if we call this function with 4, it was range of 1 to 4, which is 1, 2, 3. And it will get 10 to the power of 3. Not important for us because we know the power function. We are just working on range to see how range works. 1, 2, 3. And there are also different implementations of range with different types of arguments. You can check them all in python.org website. But the important thing for us is that if you want to iterate over a list or over an action for a specific number of times, you can put a range of that number here, and then it will iterate over that number. In this tutorial, we're going to talk about another data structure called dictionaries. We have already talked about lists and tuples. You can watch those videos if you've got any questions about them. And today we're going to talk about dictionaries. But what are dictionaries? As you know, in a dictionary, you check up a word and then it gives you the meaning of that word together with some examples and so on, depending on the dictionary. But dictionaries as data structures work the same way. As you remember, if you had a list, for example, days, and then you wanted to store the days of the week in that list, you had to write something like, for example, Saturday, Sunday, Monday, and so on. In this way, you could write the days of the week inside a list, and then you could access them using their indices. But what are the indices? As you remember, this one is index 0, this one is index 1, and the last one is index 2, and so on. But what if we wanted to access the data using a keyword? To be more precise, let's consider a street. There are some stores and houses on the street. There are two ways to address these houses and stores. The first way is to call the numbers. For example, Main Street number 5, Main Street number 6, Main Street number 7. And we know that usually the streets start with number 1 or 100 or whatever, and then the numbers increment, and then you can access the streets by their numbers. But maybe you don't want to access the stores and houses by their numbers. You want to access them by their owners. For example, I want to see where John's shoe store is on Main Street. Or I want to see where Mrs. Brown lives on Main Street. You are now accessing them by the key, not by their numbers. Of course, the key can be their number, and the key can be their name. The key can be any criteria that you determine for your data structure. But how can we access items inside a collection using a key, not the index? Let's create a simple dictionary. For example, we have a dictionary called days. As you remember, the syntax for writing lists was brackets. For the tuples, it was parentheses. For the dictionaries, it is curly brackets. And then inside this, we will have a set of key values, key and then value. The syntax is very important, key and value. What is our key? For example, we want to keep the abbreviation of every day of the week as the keyword. For example, sun as Sunday, comma, mon as Monday, comma, and so on. In order to save time, I have already prepared this list. Let me just copy and paste this list. And then I'm sure that I have to separate them by commas. And the last one, of course, doesn't need a comma. So if you want to access Sunday, you know that Sunday will be accessed by sun as a key. Now we have determined the dictionary for which the items are not going to be accessed using their indices. They're going to be accessed using their keys. How can we access the items inside a dictionary? Imagine that you want to print an item. You will write print days of and then the key. For example, mon. We want to access in days dictionary the value with the key mon. Let's see the results. You will have Monday as the result. If you wanted to see this one, you could have the same story. There is also another way to access values, and that is by using the get function. And of course, for the functions, you know that we use parentheses, not brackets. So days that get, and then you pass the key, and it will return the value for you. So we'll have the same results. As you can see, Thursday. Also for this one. But for both cases, if we misspell the key, or if the key doesn't exist here, what happens? It gives you none. But maybe we don't want this none to be printed. If the key doesn't exist, we don't want none to be printed. We want a message to be printed. That is what we can do using get function. We can give a default value. For example, we can say the key doesn't exist. This is the default value we can pass as the second input parameter to get function. Now, if we try fry, it will give us Friday. But if we misspell this, the key doesn't exist. Now it doesn't give us none. It prints us the error that we have determined for the application. Something else which is very important in the dictionaries is that the key can be whatever you like. It shouldn't be only the strings, it can be numbers. You can, for this one, you can say the key is 100. For Monday, you can say it is 101. Also here 102, and so on. Now, if you want to access Friday, everything is okay, and you will get Friday. If you want to access Monday, you need to write the proper key for that. But it is always suggested to keep the keys the same data type. If we change the data type, it is very difficult to access the data inside your dictionary. You will get confused while writing the code. So please try to keep the same philosophy behind determining keys for the elements. For example, you can keep numbers, or we can keep the same strings or whatever, but the philosophy needs to be the same. So the difference between dictionaries and tuples and lists was that the items inside tuples and lists could be accessed using the index, but in dictionaries we set a key for accessing an item inside the collection. In this tutorial, we're going to talk about two-dimensional lists. But what are two-dimensional lists? Let's go through an example to understand what they are. Imagine that you've got a cube and you want to store the width, length, and the height of this cube inside a list. Maybe it is 2 by 3 by 5. As you know, each dimension is a primitive type, number, an integer. And then if you want to store 3 values inside a variable, you need to use lists. So now you have got the dimensions of a cube inside one list. But what would you do if you had 5 cubes? How do you want to store 5 cubes in a data structure? If you want to put them together, for example, the next cube is 3 by 5 by 8, and then the number grows, it will be really confusing to store all the values inside one list. That's where two-dimensional list saves you. But how do we determine a two-dimensional list? First of all, we open and close brackets because we are going to store a list of cubes. This list contains some cubes, but each cube is also a list of dimensions, a list of numbers. So we use open and close brackets again inside. We have a list of lists here. Maybe the first one is 2 by 4 by 3, width, length, and height. Then we will separate different cubes by commas, as in simple list. And then the next cube is maybe 3 by 6 by 4. And then the last cube, which is maybe a bigger one, for example, 10 by 15 by 5. Now we have got a list of cubes. Each item contains the list of dimensions of that cube. How do we access each element inside this list? For example, you want to see what are the dimensions of the second cube. Let's call this variable cubes, and then we write, for example, cubes 1, because the index starts from 0. This is index 0, and this is index 1. Now if we print the results, we will have this list as the output. Let's see. As you can see, 364 is the output. But what if we wanted to know the length or the height of second cube? We would add another bracket, and then for this one it is index 2, 0, 1, 2. So from cube 1 we will get dimension 2. Cube 0, 1 and dimension 0, 1, 2. So we will have 4 as the output. In this way you can access each item inside this two-dimensional list. Let's do some iterations over the items inside this list. For example, we want to print the capacity of each cube inside this cube's list. What do? We need a for loop for the cubes, and then another for loop to multiply these items inside each cube. So we consider a for loop in which we have per cube a variable So for cube, in cubes, this name can be whatever you like. If you've got any question, you can refer to our for loop tutorial in order to see how can we work on fors. We are going to create a nested for loop here. This cube value will have at the first iteration this item, then this item, and finally the last item inside this cubes list. But for each iteration, we want to have the result. We will set it to 1 because we want to multiply all the items, and then we will iterate over each side of this cube, and then we will set result equal to result multiplied by side. Let's trace our program now. We will iterate over each cube inside the cubes list. So the first run, this value will be stored inside this variable cube. Then we will set result to 1, and for each side in this cube, it means first 2, then 4, and after that 3, we will multiply result by that side. Now side is 2, result is 1. 2 multiplied by 1, 2. In the next iteration, side gets 4, and result was 2. 2 multiplied by 4, 8. Result is 8. Side gets 3. 3 multiplied by 8, 24. Result gets 24. And then we will get out of this loop because we have reached the last item inside this one. And then we want to print the result. Take care about the indentation here. We want to print the result after this for loop finishes. So we want to get outside the scope of this for loop. And then we want to print result. If we run this program, we will have the capacity of each cube printed on the screen. 24, 72, and 750. Please take a deeper look at this example and try to understand how our nested loop works and how you can use two-dimensional lists and access the items inside them. In this tutorial, we are going to talk about comments in Python. Comments are a part of code which we write to get information to the person who is reading this code, but is not going to be a part of your program. Python doesn't interpret. What does it mean? Imagine that you have got a part of code, for example, you have a very simple print sentence, and you simply want to print something, for example, hello there. But you want to tell people what this part of code does. You want to say, for example, this line prints hello to the user. But as you see, this is an error. You cannot give information to the person who reads your program here. If you run this program, it gives you an error. It doesn't understand this line. By using comments, which is the sharp sign here, everything you write in front of this sharp is a comment. It is a part of information that you can give to someone who reads this class, and it is not going to be interpreted by Python. Python ignores all these lines starting with this sharp sign. Now if we run the application, you can see hello there is printed. But why do we use comments in programming? There are some reasons behind using comments. The first one is to give some information, for example, saying how your application works, or giving some information about the implementation details of your algorithms for people who want to modify it in the future. There is another usage. Maybe you have a line of code like result equals to 3 multiplied by 2.7. When you want to debug your code to understand the problems, maybe during debugging you don't want one part of your code to be executed. You can comment that part of code and then start debugging and see the results. When you want to execute that line, you can just uncomment that part. In this way, you don't need to delete a part of code and again put that part of code in place. You just comment the parts you don't like now, you don't want them to be executed, and then uncomment them when you want to reuse them in your program. But be careful about the comments. If you write a comment, you have the risk that when you change your code, you don't change that comment anymore. And then when you refer to your code again in the future, or someone else is reading your code, the comment is different from what you have written under that. So it is very important to change the comment if a part of your code which is related to that comment changes. It is better not to use comments a lot in programming, but try to use variable namings the way that everything is explained and everything is clear for the user. In this way, you don't need any other comments in your program. In this tutorial, we're going to talk about classes, the essence of object-oriented programming. But what are classes and why do we use classes? Classes are used to organize our program, to design real-life entities. As you may remember, we have talked about primitive types. Primitive types were strings, were numbers, and booleans. Strings were the ones inside double quotation. Text. It can be one character, a word, or a book, whatever. Numbers were the numbers, simple numbers or whole numbers. And booleans were only true or false, as you remember. Of course, we had some data structures where we could have a list of primitive types. We could have a dictionary. We could have a tuple of those primitive types. But are they really enough? Can we model real-life entities using primitive types and lists? Of course not. Imagine that you have got a soccer team and you want to model that team in your program. Imagine that you have got a product that you want to sell on your website. This product has a name, has a color, has an ID, has a price, discount, and so on. There are many different values that you can give to this object in the real life to describe it. And there are many functions you can do, you can implement on this object that you cannot implement on other entities. The things related to soccer players are different from what you can do on basketball players or on products or on fruits or flowers. So each entity needs to be explained to the program. The program must understand what are real-life entities in order to work on them. Classes are the best choice here. We use classes to model real-life entities. But how do we create classes and how do we use them? From now on, I have a suggestion for you. When you want to create a class, create it into another file. In this way, your program will be structured and organized. It will be very clean and your files will not go very long. So I would suggest that if you want to create a new class, create it in a separate file. We have a project called classes, and then on this project I will create a new Python file, and imagine that we want to create a class for soccer players. So we call this file as soccer player. This is a Python file, and as you can see, soccer player is created here. We have our app which we write our program here, but also we have got our soccer player here, and you can see that this soccer player is added here. When you run program, you can determine, also you can take a look here, where your program starts from. Of course, you don't want to start your program with a class. You want to use this class in your main program. So here we choose app as the starting point of our class, so the class starts here. But how do we create a class for a soccer player? First of all, we have to use the keyword class. And then inside that, let me just zoom a little bit on it. And then the name of this class is player, for example. For the classes, we prefer to start names with capital letters. Now we have got a class called player, colon, and then we enter the scope of the class. What are the things that we can have in class? We can have functions in a class that we call them methods, class methods, and we can have attributes in each class. But there are some initial attributes that you want to give when you want to create a player. The constructor is the first function which is called when you want to create an object from this class, when you want to create a new entity using this class. The first function which is called automatically by the system is the constructor of this class. How do we write this constructor and what do we write inside it? As you know, it is a function. From now on we call functions inside classes, we call them methods. We write def, and then there is a keyword for constructors which is underscore underscore init. As you can see, I will just press enter. It recognized that with a color code, and then it wrote a self inside here. What is this self? I will talk about that later. But for now, keep in mind that this self is really important. After this self, we will determine some entities. It doesn't mean that this class has only these entities. You can later on add other entities, but we want to add important entities that when we create a new class, we want our player to have these entities at first. For example, we have name, age, the team the player plays in, and then maybe injured status, if the player is injured or not. These are the input parameters that when we create a class we get from the user. But what should we do then? We have to assign these variables to our object variables, to this person, to this player. How do we do that? By writing self, which is this self, dot name, and then we assign the name that we get. So self.name, it means my name. I will put this one as my name, the parameter that I get from the constructor. And we will repeat everything for the others. So now we have assigned these input parameters to variables which belong to this player that we have created. Maybe we want to add another function to this class that gives you the complete status of a player. So def get status. Be careful again, this self is necessary, and it automatically puts it here if you just open and close parentheses, as you saw right now. But if it was forgotten by Python or something happened, you have to put this self inside. Don't worry about this self, I will explain it now when we create new objects from this class. But what do we want this print status to do for us? We want to print all the information related to that layer. What are those information? We want to see self.name plus a space, maybe a dash, and then we want to see his or her age. We want to see his team, and then we want to see if he is injured or not. Injured, and then self.injured. So get a status prints out all these information for the user. Take care about this self. It must be present. If you remove this self, it gives you an error. It doesn't know what name are you referring to. There is no variable name here. We have a variable name, but it is related to one class. It is not an independent variable. It is a variable for this object. So self.name. Alright, now that we have got a class, let's create our players inside our main application. But in order to use this class, we have to import it because it is in another file, and this file doesn't contain any definition for soccer player. So we say from soccer player, it recognizes import from this file. What do we want to import? This class, player. Import player. And then we want to use this player. For example, the most famous players at the time of creating this video, which are Messi, which is a player, and then we have to call the constructor. What was the constructor? This is the constructor. And when we say self here, automatically this self is this Messi, this name here, this object here, and then it is waiting for these values to be passed as input arguments. So if I clean this one and open and close parentheses again, you can see that it is suggesting me name, age, team, and injured status for this player. So we will write Messi, for example, as the name, as the age, maybe he is 32 years old, as a team, currently he plays in Barcelona, of course, first C, and then he is not injured, so we'll put it false. And as you see, we have entered all input arguments, input parameters, and everything is done. Now let's create another player to understand the meaning of self more clearly. If we create another player, for example, Ronaldo, we put the name here, age, I think he would be 33, and he plays in Juventus now, and he's not injured. When this player constructor is called for each of these players, as you can see here, it passes the self and it says, okay, let's create a new player. What is this player? This is this variable, whatever the name is, not important. This variable here. Okay, from now on, whatever you do, we do on this variable, on this object of the class. So every instance that we create from a class is called an object. For this object, set the name to the first input parameter, set the age to the second input parameter, set the team as the third one, and set the injured status as the last input parameter. As you remember, here we entered age as a number, name and team as strings, and injured status as Boolean. So we have one entity for which we have many different types of data. And you could even have a list of teams, previous teams, a list of, I don't know, maybe houses that he owns. For a product, for a company, you could have discount number, price, and the list of stores that have this item, and so on. All right, imagine that we want to see all the information related to these players. What do? We will just call Messi dot. If we put dot, we have access to all attributes called injured, age, name, team, and also to all the functions or class methods like get status. Also init and these others are the pre-built functions on class objects. We are not going to talk about them. We have talked about init, but init is not written like this. When you create an object, it is automatically called. Now we have access to all of these. We want to call get status. And that's enough. If you just call get status, it will write the status related to this player. But be careful, the age was a number. And as you remember, you cannot concatenate numbers to strings. So you need to change it into int. Write a code once and use it many times. Organize your code. Let's call the same for Ronaldo. And let's run our program to see the results. Come on, it gives me error. I had to convert this self.age into string, not to int again. It is an integer number. str. Let's run our program again, and then we have got another error saying that boolean is also needed to be changed into string. So str again here, and now we can run the program. Perfect. Messi, 32 years old, Barcelona, injured, false. Ronaldo, 33, Juve, injured, false. And imagine that we want to change the injured status of a player. For example, here we say Messi dot injured equals to true. Something happens and Messi gets injured. If we run the program, you can see that this injured status is changed into true for Messi, but for Ronaldo it is still false, because for this object, for this self, we have changed or modified something. Here the age is fixed. You can have a function here, and then you can get the birthday of a player, and every year on his birthday you can increment this age variable. So you can do whatever you like for this class, and it will be applied on all implementations, all objects that you create from this class. I hope you have enjoyed this course. I suggest you to create different classes for different entities and call them inside your program. Try to use them a lot, because if you don't use them, you cannot learn them. Don't forget that practice makes perfect. In this tutorial, we're going to talk about inheritance in Python. But what is inheritance? Let's go through an example to understand the benefits of inheritance and how to use that. First of all, in order to talk about inheritance, we want to create another Python file in which we want to add some code. So we'll create a new Python file. We will call this file as people. Why people? Because we want to determine some characters, some people inside this file. Alright, now that we have this file, let's talk about our program. Imagine that we want to have a program for a school. In a school we have got different roles. We have got a teacher, we have got a student, and then we have got a principal, and so on. So there are different roles inside the school. And imagine that we want to have separate classes for each role. For example, we have a class. Let's zoom a little bit inside. We have a class for students. So we call this class student. And then in this class, as you remember, we need a constructor. Of course, it is optional, but we need our constructor in this class to instantiate a class and initialize that object. We use def and then init. Using self, we want to give that person first name, last name, and age. So we will give self that first name, the first name. We'll give self that last name, the last name. If you've got any questions about what I am doing right now, you can refer to our previous tutorial about classes. I will also explain that a little bit after I finished up with this phase. Now we have created a constructor. So when we create an object of class student, it means for each student we want to determine what specifications that this student have. We will pass as input arguments, input parameters, the first name, the last name, and age, and self refers to the current object. So for this object we will fill these three variables as the entered parameters. Now imagine that we have got a function for this class, a class method that is going to print user's first name. So we'll call this print first name. And what is this class going to do? Only print self dot first name. And then imagine that we have got the same and then we call this one last name, and we will print self.lastname. We have got another function called print info, which is going to print all the information related to that person. How do we define this function? We want to say, for example, I am a student, and then my full name is self.first name plus maybe a space and then self.last name. So we are going to print all the information for this user. Alright, now we have written the whole class for the student. Of course, in a real case scenario, the class has different functions and different functionalities, but now we want to keep everything simple. We have a student class. In the constructor, we get the first name, last name, and age, and we have got three different methods, class methods, which print the first name, the last name, and the full information of that user. Let's create another class for the teachers. So we'll have a class called teacher, and in this class, imagine that we have everything the same as in a student, because the teacher also has a first name, a last name, the age. We will fill the variables. We will print the first name, the last name. The only difference is here we want to say I am a teacher but not a student, and then the full name. We'll print the full name. Now if we want to use these classes here in our main application, we can generate objects from this class. But first of all, we have to import everything here. So we can say from people import student. Also from people import teacher. So we have imported teacher and student from this class. Let's create a student. Maybe student 1 is a student, and as you remember, we have to pass. PyCharm will give you hints: first name, last name, and age. Maybe the first name is John, last name is Brown, and he is maybe 15 years old. Then we have got a teacher. We have teacher 1, which is a teacher, and as you remember, also in teacher class we need to pass first name, last name, and age as the input parameters. Maybe the teacher's name is Martin, his last name is White, everyone is a color, and then maybe he is 44 years old. Now we have access to all the functions, the class methods that we determined for each of these characters. For example, we have student1 dot. After dot, you can see that we can access last name, first name, age directly. Also, we have access to print info, print first name, and print last name as the class methods. So we will write, for example, print first name, and then also maybe we want to print all the information related to that user. For teacher 1, maybe we will also want to print information. If we run this program, we are waiting for John to be printed, and then the whole information, which means I am a student, my full name, come on, my full name is John Brown, and for teacher also I am a teacher, my full name is Martin White. Let's run and see the results. I am a student, my full name is John Brown. I am a teacher, my full name is Martin White. But what if we wanted to add other characters? This file goes very long with a lot of characters which have these lines in common. So it is not a good idea to repeat the code. There is a rule in programming called dry. Don't repeat yourself. One of the ways to implement dry, don't repeat yourself, is to use inheritance. We will create a base class called person, maybe, whatever you like. And then in this class, we will pass all these functions. So class person has a constructor with these input parameters. It has print first name, print last name, and print info. And in the print info, we don't want to write I am a student because it is a person, it is a general class. So my full name is, and then write the full name only. Now in student class, we want to say we are a student, but we want to inherit from person class. So inside parentheses, you can inherit from a class. And when you inherit from a class, you have access to all functions and attributes in that class. So we don't need to write these functions anymore. But what about print info? If we also remove this one, when we call print info for a student, this information is going to be printed. But maybe we want to also add this one, add this sentence, I am a student, to the start of the sentence. We will override this function. So it is called overriding. What does it mean? To override a function with the same signature. What is signature? The way you declare a function. It means a function with this name and this set of input arguments. Here we only have self, and here also we have only self. So for this signature, we want to give another functionality. So we will repeat the same signature but alter the functionality. So we will override this function for a student. Say I am a student, my full name is first name and last name, and not my full name is whatever. For the teacher, we have also the same story. As you can see here, print first name, print last name, and the constructor are still the same. For print info, we are overriding this print info in the person class. It means that whenever someone calls teacher.printinfo, we don't want this one to be executed. We want this print info function, which adds I am a teacher at first. Come on, here also, sorry, I have to remove this A. All right. So we have provided a base class because we didn't want to repeat some parts of code which are common in different classes. So if you add other personnel to a school, all of them can have a constructor, can have print first name, can have print last name, and print info as a simple way if they inherit from this person class. Let's call our program again. We have student 1 like this, teacher 1 like this, and we don't want to change anything here. Let's see if there is any errors. Teacher Martin White 44 teacher takes no argument. Why does it give me this error? Because maybe for teacher I have forgotten to call person. Yes, here I have to add person as the superclass so that it recognizes what is the constructor of my class. Let's run this app again, and here say I am a student, my full name is John Brown. I am a teacher, my full name is Martin White. So if we call student 1 and put a dot after that, you can have access to all the functions inside class student 1 and also inside the base class, which is person. You can see that print info comes from student class, while print first name, last name, first name, age, and print last name all come from person class. For teacher 1, we have also the same story. If we put a dot after teacher 1, the print info function comes from teacher class, while everything else comes from person class. We have got another benefit here. For example, for student, if we add another function, for example, print age, and then we want to just print self.age for student class. You can see that this function exists for student class, and since teacher doesn't inherit from student, teacher does not have access to this class. For teacher, print age doesn't exist because teacher inherits from person. Whatever exists here also exists for the teacher, and also whatever we write for the teacher. But whatever is here in student does not exist for a teacher, not even for a person. So here, if we write student1 dot, we have got print age here, as you can see. If we write print, you can see print info, print first name, age, last name. But for teacher1, you have only print info, first name, last name. We don't have print age anymore. This was the essence of inheritance. Of course, inheritance is very vast. You can read a lot about inheritance in python.org. In this tutorial, we're going to learn how to read files. In order to do that, I have created a text file called films.txt. I have put it in the same directory where my application files are, so I don't need to give a complete path, and I can give a relative path to this. I will talk about that later. But in this simple text file, I have got a list of 3 films: Malena by Giuseppe Tornatore, Rain Man by Barry Levinson, and The Godfather by Francis Ford Coppola. And in our application, we want to read this file. Keep in mind that now we are going to read a text file, but we can read every type of file using Python. And of course, there is plenty of pre-built libraries that you can use in order to read different types of files, like XML, like JSON files, like CSV files, and so on. We're going to work on a very simple one, which is a text file reader, and we want to read these films. In order to do that, we need to create a variable for the file to put the file inside. We call that variable films file, and then in this file we want to open this films.txt and put everything inside the films variable. How do we do that? We use the open keyword, and then inside open keyword we have to determine the path towards the file. Because it is a relative path and we are here in this directory, we just need to give the name of the file, which is films.txt. But in case you wanted to give an absolute path, as you can see here, C :users Reza M PyCharm projects read file, you can give it like this. So you could do like this, and then give the directory where your file is. For us, this is enough. And then you have to determine the mode that you want to open this file. Now we want to read, so the mode is only read. But there are different modes that you can use. When you want to read something from a file, you have to use this R mode. If you want to write something to a file, you will use W as the mode. And what does this W mean? It means that if the file exists, it opens the file, and if you want to write a line, it will overwrite the file. It doesn't append to the file. It will write everything from scratch. So it deletes the file and writes everything on it. If you put A, it means append. It means that you want to add something to the end of the file. So it opens the file, and then you can, using the keyword write, you can write the files. In the next tutorial, we'll learn how to write on the files. And then if you use R plus, it means read and write possibilities. So if you write R plus, you can read the file and you can write to the file. So just to make it more clear, if you write W here, you cannot read the file anymore. You can only write on the file. Now we want to read the file, so we use R, and then in order to see if we have done everything correctly, we will print films file dot readable. This readable function returns true or false. If this file is readable, it will return true. Because we have opened it with mode R, it has to be readable and it will return true for us, hopefully. Yes, it returned true. If we change this to W, it has to return false because it is not readable anymore. Let's check. As you can see, false is returned. So we are sure that with mode R, we can read the file correctly. Now let's read the first line of this file. Read line. As you can see here, the file is deleted. Why? Because we have opened it with W, and then when opening with W, it will open the file and clears everything inside that file. I will just reload the file by Ctrl Z, and then we will come here and then read the first line. The first line is supposed to be Malena by Giuseppe Tornatore. Let's run the program to see if the first line gets printed. Malena, Giuseppe Tornatore. So it is working perfectly. We can read files line by line like this, or we can read all the lines inside one separate file using read lines function. And then we can print these lines. But what is there in this line? This is a list because this read line returns a list. As you can see here, it returns a list of string values. So it returns a list. This list has 3 items inside, which are each of these lines of code. So if we print this one, it will give us a list. As you can see, the list starts with open brackets, Malena, Giuseppe Tornatore, comma, Rainman, and then the other, and then finishes the list. But if we want to get access to real lines of code, not to a list, we can iterate over that list item. But just be careful about this \n. Each line ends up with a \n. It means enter. When you press enter on a line, it goes to the next line. This one is not needed for us. Actually, we have to get rid of this. Also, we have to get rid of all the spaces at the start and end of the file. So imagine that in this file, we put some spaces at the end. Then if we run this program, let's save this one. And if we run the program, you can see that there are many spaces here and then \n. We don't want these spaces and this \n. How can we get rid of these? Let's read the lines one by one. We can say for line in lines, as you remember, for loops. Then we want to print line and not lines, line. But if we print a line, we will have Malena, Giuseppe Tornatore, all of these spaces. We don't have \n, but it goes to the next line. What does it mean? It means there is a space between the lines. Let me show you what it shows. Malena, Giuseppe Tornatore, next line. And we know that print automatically goes to the next line when it is called for the second time. So we have got one enter or \n at the end of each line. And then we have got one enter after this print. So we have got 2 next lines. In order to avoid that and also avoid the empty spaces at the end of each line, we have this strip function we can call on each string. This strip function removes all the new lines and empty spaces before and after each string. return a copy of the string with leading and trailing white space removed. So if we run this program now, everything is as written here in the real file. Malena Giuseppe Tornatore, it will remove the \n here, and print automatically goes to the next line and prints everything inside the file. In this tutorial, we're going to learn how to write to files. Last session, we talked about how to read the files. As you remember, we had a films.txt file on which we had 3 different movies: Malena by Giuseppe Tornatore, Rain Man, and The Godfather. And then we read this file using open keyword. We gave the path of the file here. You remember, if you wanted to give absolute path, you could do like this, but since this films.txt file was in the current directory where the application file exists, we just needed to write the name of the file, and then we chose the mode to open this file. As you remember, we talked about different modes. There is R, which is the read mode. If you use R, you can only read the file. You cannot write anything to a file or append anything to the file. You can just read the file. If you use mode W, you can write to a file, but you cannot read it anymore. And if you want to write anything to the file, it will overwrite the file. So it will clear the file and write from scratch. If you use A, it will append things to the file. It means add the things to the end of the file. And if you use R+, you will give the possibility to read and write a file to this variable. Then in the previous session, we used reading files. We had this variable called lines, which reads the whole file, and line by line prints on the screen what existed inside the file. Now in this tutorial, we're going to write into this file. First of all, we use A, which is for appending the file. We open the file in this variable. Then we want to write to the file. What do we want to write? For example, we want to write, this is an extra line, and we want to write this line at the end of the previous file, but to the next line. So using \n, we will go to the next line. So we will write everything to the line after this Godfather Francis Ford Coppola. So we will have a line 4 here with the text, this is an extra line. And then we want to just end the program. Be careful, if you open the file, you have to close it at the end. So films file dot close. Finally, let's run this program. As you can see now, the films file contains 3 lines. If we run this program, you will see nothing printed on the screen because we have done nothing to be shown on the screen, but this file contains, this is an extra line at the end. So we have done an append. We have opened the file in the mode append, so we're going to add something to the end of the file. But what if we use a W, which is mode write? It will remove everything in this file and it will just add this line to the first, and because we have got \n, it will write this line to the second line of our file. If we run the program again, you can see nothing is printed here, but the program is executed. Line 1 is nothing because we have \n, and on line 2 we have got this text file. In this way, you can write things on text files, and of course, if you want to write things on CSV files, XML files, JSON files, and all different types of files, for sure there are pre-built libraries for all of them. I hope you have enjoyed this tutorial. We talked about how to write on text files. If you've got any question, please ask me in the comments under this video. I will answer your questions as soon as possible. If you like this video, please give us thumbs up and subscribe to our channel to encourage us to create more videos. Have fun and don't forget to practice.